Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, hello, my students. Actually, this is intensive course, but yeah, I will continue my materials. Our materials about turning forces, yeah, turning forces, and maybe most of you have done the assignment about turning forces or moment. Okay. Now I directly to share my materials. This is okay. This file have, I think you have received, ya, this file ya. Sudah diterima ya filenya. I ever search in group. Okay. We discuss about turning forces, and in this topic, you will recognize when a force causes something to run, and then know how to use the term moment, and then be able to calculate the moment caused by a force. Okay, but we will not work in groups. Yeah, we just discuss. The keywords is lever, moment, Newton meters, pivot, and turn. Maybe add the other reference. Yeah, the other reference. Pivot can also become fulcrum. Okay, fulcrum. What is pivot or fulcrum? Okay. What is pivot or fulcrum? We will discuss about after this. Yeah.
I thought tuas.
Yes.
Kak, jadi Pak.
Okay. Okay, we continue. Turning effects of forces. Yeah. Okay. These are the illustration of moments. Yeah, moment or turning forces. Atala Rasya.
Yeah.
Okay, read the text, Atala Rasya.
Turning effects of force. When you push down on a door handle, the handle turns. When you push down on the pedal of this bicycle, the pedal turns. When you pull on a door, the door turns toward you. These are these are all examples of force that cause an object to turn. The object that turns is called a lever. The point around which the lever turns is called the pivot. The lever and pivot are shown in the picture of the bicycle pedals in figure 3.4.1. When you bend your arm, the arm acts as a lever. Your elbow is the pivot.
Okay, thank you so much. Pivot,
Okay.
or maybe the other reference called fulcrum is tumpu. Titik tumpu. Maybe you ever known about the concept of lever or simple machine, ya. Mungkin kalian pernah tahu tentang pesawat sederhana atau simple machine, and maybe you ever know about lever. Lever is pengungkit. Tuas, ya, tuas. Okay, this is the illustration in our bicycle at pedals show about the lever and also the pivot, and maybe our hand, yeah, our hand. There will be a pivot or lever when we do some activities, yeah. So this is the handle turns, yeah. And when you push down on a door handle, you push down a door handle, yeah, that is the moment also, yeah. And then the object that turns in is called a lever. The point around which the lever turns is called the pivot, yeah. Okay, thank you so much, Mas Atala Rasya. Now, this is the calculating moments, yeah. The moment of a force describes it's the turning effect of a force. The moment of a force depend on two, okay? Depend on two things. The first is this one, the size of the force, the bigger the force, the bigger the moment, yeah. If the force is bigger, the moment also bigger, yeah. Second, okay, the moment of the force depend on the distance between the position where the force act and the pivot, ya. Jadi jarak antara titik tumpu dengan titik di mana kita memberikan aksi. You can calculate a moment from this equation. Yeah, the greater the distance, the greater the moments. Like force, yeah. If the distance is greater, the moment also greater, ya. Kalau panjang antara pivot and the act position, posisi untuk kita melakukan aksi itu tambah panjang, maka the moment also greater. The force, if we give the force greater force or bigger force, so the moment also bigger. Yeah. Moment equal with force multiply with distance. Okay. Don't worry, we will practice some questions here. Okay. Now we try to answer this question. Distance, okay, Mas. Mbak Karina. Assalamualaikum Mbak Karina. Halo. Respon. Mbak Fania. Assalamualaikum Mbak Fania.
Waalaikumsalam.
How are you today?
I'm fine.
Very good. Now Mbak, before work examples or before reading the questions, would you like to read from here until here? Okay, please.
Oh, okay, Pak. Distance in the unit equation is the distance from the pivot to the position where the force acts. The unit of force is the Newton and the unit of distance is the meter. Therefore, the unit of moment is Newton multiple meter, which is written as Newton meter or Nm. Remember to use an uppercase N and a lowercase m when writing Nm. Question: a pulling force of 35 Newton is needed to open a door. The distance from the door handle to the door hinge the pivot is 0.8 meter. What is the moment caused by the pull on the door?
Okay. Question, but this is remind us, remember to use an uppercase N for newtons and lowercase m for meters, ya. Itu N-nya besar, M-nya kecil. A pulling force of 35 newtons is needed to open a door. The distance from the door handle to the door hinge or pivot is about 0.8 meters. What is the moment caused by the pull of the door?
28 Newton.
28?
Newton meter.
How come?
28 Newton meter.
This is what is this?
This is 35 Newton.
What?
Force.
Force.
Okay, good. And then what about 0.8?
Distance.
Then okay. So the moment.
So the moment is force multiple distance.
So 35.
Multiple 0.8 meters is 28 Newton meters.
28. I'm so okay. Thank you, Mbak Fania. 28. Oh, too faster. Oh my God. Okay, this one. Okay, this one, yeah, 28 Newton meters. Okay. I think there will be some questions that we can use for exercise. Okay, now I need help from Mbak Alisa Syafira Rianda Putri. Halo Mbak Alisha, Assalamualaikum. Your voice. Halo Mbak Alisa.
Hello.
Okay, good. Now I need you to read these questions and help me to answer these questions. This
Which
one,
one?
please.
Look at this diagram. What's the moment caused by the weight of the arm?
Okay.
The moment.
Okay. Look at this diagram. What is the moment caused by the weight on the arm? So there are two quantity, Mbak Alisa.
Yeah.
There are two quantity here, 0.25 meters and also
5 meters.
wait.
What?
0.25 meters and 20 newtons. There are two quantity here. So what is 0.25 meters, Mbak Alicia? Is it distant?
Suppose.
Okay, meters indicate that the quantity is about length. Isn't it? Meter. So what is 0.25 meters? Is it distant?
Not sure.
Oh. There are only two quantity about moment, like the answer of the prior questions. Yeah, moment, force, and distance. So which the force and the distance? Yes.
Oh yeah. It.
The distance is based on these questions. Okay, may I help you? Yeah. 0.25 meters. Oh my. Wait, there is a problem. Okay. 0.25 meter is distance, and then 20 is force, Mbak Alisa. Why? Because from the diagram, 20 newtons. So to us that is the weight force, and then 0.25 is distance between the force and the pivot. Okay,
5.
and the equation of moment is equal with force multiple with distance. So Mbak, the moment will be equal with the force is, what is the force?
The force 20
20
ton.
20
newtons. Good. And then multiply with the distance is
0.25.
yeah, oh point
0.25.
0.25 meters. Okay, you have to remember that n in uppercase, m in lowercase. 20 multiplied with 0.25. What is the result?
5 Newton meter.
5 Newton meter.
5 Newton meters. Okay. Okay, good. So the result about 5. Don't forget to write the unit newtons in uppercase and meter in lowercase. Okay. Wait. Wait, yeah. Okay. I think the answer is 5 newtons, yeah, because 20 multiply with 0.25. I need to document this. Okay, we continue with our lesson, and I share again my materials, and this is have done. Now we go to the next about balancing. You know, balancing. Before we answer the questions, I need Mas Hamam to read the materials about balancing here. Mas Hamam, please help me to read.
Balancing. A seesaw is a type of lever. People sit on either side of the pivot of a seesaw and make the lever turn on one way and then the other. The result is that each person moves up and down a seesaw will be balanced when the moments on both sides of the pivot are equal or opposite.
Okay, thank you so much. We say about balancing. Balancing, if we discuss about lever, it means that just imagine there are two sides of the lever, right side and left side. Ada sisi kanan, sisi kiri. Balancing happen when when the moment of the left side and the right side is the same. Yeah, the moment. I mean the magnitude of the moment. Yeah, but the direction is opposite. Jadi balancing itu terjadi kalau momen gaya dari dua buah momen itu sama. Biasanya di lever ya atau pengungkit, force multiply distance at the right side is the same with the force multiply the distance at the left side. Yeah. So now we go to question Mas Hamam. Please read the question Mas Hamam here.
Marcus with a weight of 6 distance off from the pivot of a seesaw. Aaron has a weight of 800 Newton. Where should Aaron sit to make sure the seesaw is balanced?
Nah, ini ya. Marcus with a weight of blah 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 sits at a distance of blah 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 from the point of seesaw. Aaron has a weight of 100 newtons. Where should Arun sit to make sure the seesaw is balanced? Ya, ini untuk untuk menyeimbangkan ya. Nah, ini di sini belum ada informasi tentang Markus. Actually, there is no information completely about Markus, but it's okay. Ya, kita langsung saja. Markus will exert a moment of 600 multiply to or about 1,200 Newton meters. Jadi maksudnya ini langsung ya, ini belum ada ya. Ini kita isi 600 dan 2 sehingga kita anggap saja untuk Markus 1200. If this lever in balance condition, so the moment is the same, must be the same between Markus and Arun. If the moment of Markus is about 1,200, so Arun also must be 1,200. And the question, where should Arun sit to make sure the seesaw is balanced? So the question is about distance. So distance equal with here, distance equal with moment divided by force. Distance is moment, moment is 1,200 because same with the moment of Markus and divided the force of Arun is about 800 newtons. So the result is 1.5 meters. And we have to know that actually the question must be stated the moment of Markus first if we want to find out the position of the Arun ya. Jadi Markusnya harusnya diketahui duluan di 1200 ini. Nah, kemudian momen Markus must be the same with Arun. Jadi momennya Markus itu pasti dan harus sama dengan Arun supaya balance ya, seimbang. Gitu. Oke. Continue. Okay. There are many questions. Okay, I think ya Mbak Sarah Diana Amalia. Assalamualaikum Mbak Sarah.
Waalaikumsalam Ustadz.
Oke, Mbak Sarah. These are the questions, some of them asking about concept. Now I give you a chance to answer number 1.A, please.
1A.
Yes.
Describe what is meant by the word moment in physics.
Okay, please. In bahasa it's okay if you want answer in bahasa. Pakai bahasa Indonesia boleh.
In physics, a moment is an expression involving the product of a distance and physical quantity.
Thank you so much. I think your answer based on the materials, yeah, based on the ebook. Yeah. Describe what is mean by the word moment in physics. Ya. Jadi kita disuruh mendeskripsikan momen itu di dalam fisika itu apa sih? Gitu. Yang pasti moment is one of the quantity, one of derived quantity, satu dari contoh dari besaran turunan, ya. Di mana momen itu menunjukkan besaran, show the quantity that related with the moment, the force and the distance, the point that influenced by the force. Jadi momentum. Momen itu adalah, ini momen gaya ya, bukan momentum. Momen itu adalah salah satu besaran yang menunjukkan ada gaya yang juga dipengaruhi oleh jaraknya terhadap titik yang dipengaruhi oleh gaya tersebut. Jadi, if we have discussed about concept greater moment, greater force, greater moment, and greater distance, greater moment also. Ya, jadi kalau kita jarak pengungkitnya kita tambah, ya, antara pivot dengan effort, ya, antara pivot atau fulcrum dengan gaya, maka kita akan mendapatkan momen yang besar. Sehingga kalau kita pengen mengungkit itu kan lengan kuasanya harus lebih gede supaya kita mendapatkan keuntungan mekanik yang besar. Ya, so moment have related with simple machine, especially for lever, and maybe for the next meeting we will discuss about mechanical advantage atau keuntungan mekanik. Ya, biasanya kalau kita mengenal lengan kuasa, ya, pivot arm, ada pivot fulcrum atau titik tumpu. So titik tumpu, there are two terms that I know from the other reference. In this reference, we say fulcrum, titik tumpu is pivot. But maybe for the other books, buku yang lain menunjukkan atau menyampaikan bahwa titik tumpu sometimes called as fulcrum. Okay, thank you Mbak Sarah Diana for number 1.8. Now Mas Rizky Rakananta.
Ya, Ustaz.
Rizky Rakananta, how are you today?
I'm good.
Okay, thank you. Now please read questions number 1.D.
Wait.
Okay. Number 1.B. Have you opened my share screen? Hello. Rakananta, halo.
Katanya Rizky Rakananta dia nggak bisa lihat screen-nya. Gitu,
Oke,
di chat.
thank you. Oh, chat ya. I'm so sorry. I don't read the chat. Okay. Now I go to the other. Mas Ganendra. Assalamualaikum, Mas Ganendra.
Waalaikumsalam.
How are you today, Mas Ganendra?
I'm fine.
Okay, good. Mas Ganendra, now your turn to answer number 1.B. Please read the question.
Write the equation that links moment, force, and distance.
Okay. Would you like to use your annotation? Bisa buat coret-coret nggak itu? Anotasinya. Bisa kan? Annotate. Diklik biar bisa coret-coret. Bisa? Halo? Okay, say and I will write. Say, Mas, the formula of, what is that? The equation. The equation that links moment, force, and distance. Moment, force, and distance. Please say and I write the equation. Mas? Moment
Equals
yes, equal
force
force, and then
multiplied by distance.
Okay, very good. Very good. Now directly, Mas Ganindra, number 1.C.
Write the unit of moment.
Yes, what? The unit of moment.
Newton meter.
Newton?
Newton meter.
Newton meter. Okay, thanks. Very good. Ya, betul sekali ya, Newton meter. The unit of force, how come? How come Newton meters? The unit of force is Newton, and then the unit of distance is meter with lowercase. So the unit of moment is Newtons meter, like this. Okay. Okay. Okay, number 2, I need from Mas Raka.
Yes.
Read question number 2.
John has a spanner for turning a nut. The direction that the nut must turn is shown by the arrow. The pivot is in the center of the nut. A. Which arrow shows the direction that John should push on the spanner to produce the largest moment in the direction needed to turn the nut?
Right the letter. Okay, thank you. Still on your mic ya, Mas Raka. Mas Raka,
Yes.
okay. Di on kan aja mic-nya. John has a spanner for turning a nut. The direction that the nut must turn is shown by the arrow. The pivot is in the center of the nut. Yeah, okay, like this. Yeah. And then nut will turn this way with blue arrow. Yeah. Okay. Now number 2.A, which arrow shows the direction that John should push on the spanner to produce the largest moment in the direction needed to run the nut. Okay, what is the answer, Mas Raka?
Ke bawah.
Ke bawah.
Bentar.
Write the letter A, B, C, D.
D, C, B, A. Kayak gitu lah.
What? A.
D, C.
No. Which arrow shows the direction that John should push on the spanner? Jadi yang menunjukkan untuk menekan spannernya ini itu yang supaya nutnya itu turn like this one, turnnya ke sini, ya kan? Berarti huruf apa? Nekannya pakai huruf apa?
A.
Good, very good. Thank you, Mas Raka. Now, still Mas Raka ya, still Mas Raka. Number 2.B, explain your answer to A. Jawaban yang A itu apa itu? Jelaskan kenapa kok Mas Raka milih titik tekannya di A. Mas Raka?
Soalnya kan nekennya ke bawah gitu.
Oke. Supaya nutnya itu geraknya seperti yang panah biru ya. Oke. Oke, thank you. Now, Mas Raka sudah. We go to Mas Rafa. Ya, Mas Rafa. Halo, Mas Rafa. Assalamualaikum.
Hello.
Oke, Mas Rafa, number 3.
The drawing shows door handle. Sofia poses on the Toronto with a force of 4 Newton. At the positions O in the draw, and calculate the moment caused by this force.
Okay, thank you very much, Mas Rafa. Mas Rafa, please use your computer to answer this question. Number 3. Pakai orat-oratan, Mas, silakan.
Okay.
Sudah bisa?
Ya. Coba sebentar.
Sudah bisa?
Wait.
Weh. Oke, I'll have you, Mas Raka. Mas Rafa. Clear, Mas Rafa. Mas Rafa,
Ya.
now my questions. What is 0.12?
12.
Force. Okay, thank you. A force? Are you sure?
What? Distance.
Distance. Okay, good. What is 4 Newton, Mas?
Force.
Force. So, what is the moment?
0.48.
So, what is the result?
0.48.
0.48. Oke, yang lain? Ada yang lain? The moment is 0.48. Yeah, Snit?
Yeah.
And the unit? What is the unit, Mas Rafa?
And
Meter.
Okay.
Newton meter.
Okay, thank you.
Newton meter.
Thank you so much, Mas Mas Rafa. Ada Raka, ada Rafa. Okay, we go to our lesson. And next, Mbak Hafiza. Are you ready, Mbak Hafiza?
Insyaallah.
Okay, Mbak Hafiza, now your turn. For number 4, Mbak Hafiza. Please read the questions.
The drawing shows a bicycle brake lever. A moment of 1.8 Newton is needed to turn this brake lever. Calculate the force needed at position F to produce a moment of 1.8 Newton meter.
Okay, thank you so much. Tetap on ya, Mbak ya. The drawing shows a bicycle brake lever. A moment of 1.8 newtons is needed to turn this brake lever. Calculate the force needed at position F to produce a moment of 1.8. Jadi ini yang diketahui adalah the distance. What is the distance, Mbak? Mbak Hafiza? What is the distance between force and pivot? Mbak Hafiza, mic-nya belum on.
Moment per force.
No, my question is, what is the distance between force and pivot? Mic-nya belum di-on-kan. Halo? Anyone knows what? Yes, Mbak Hafiza? Mbak Hafiza?
Enggak tahu, Ustaz.
Okay,
Enggak tahu.
the distance between force and pivot. What is the distance between force and pivot? Berapa jaraknya?
0.09 meter.
Okay, very good. This is distance. Okay. Now, the next. What is 1.8 newtons? Sorry. No. Not this. What is 1.8 Newton meters? Apa itu 1,8 Newton meter? Moment atau force?
Moment.
Moment, okay. We know the moment and the distance. The question is calculate the force needed at a position F. Jadi kita disuruh nyari force. Berarti force sama dengan apa, Mbak? Kalau moment sama dengan force multiply with distance. Kalau force sama dengan apa, Mbak Fiza?
Moment dibagi sama distance.
Very good. So, what is the result?
20.
20 ya. 1.8 divided by 0.09. Isn't it?
Yes.
Yes. Okay. Any answer else maybe? 1.8 divided by 0.09 is berapa Mbak tadi? 20 ya?
Yes.
Yes, 20. The unit is Mbak Fiza, the unit of the force is
Newton.
Newton.
Okay, thank you so much. Okay. Okay.
Apa itu yang nomor 5 tadi itu cara jawabnya gimana, Pak?
Number 5. Okay, number 5. Oh, belum nomor 5, belum dibahas. Okay. Anyone want to ask with me for number 5?
Me.
Yes. Siapa yang ngomong me tadi?
Chris.
Chris. Okay, Grace. For the first step, please read the question number 5.
Sarah weight 450 newtons. Sarah sits on a seesaw at a distance of 1.5 meter from the pivot. Sophia weight 500 newton. Sophia is on the seesaw on the other side of the pivot from Zara. Calculated the distance from the pivot that Sophia must sit to balance the seesaw.
Okay, thank you so much. Now I want to show you how to answer this question by using diagram. Okay, not good, yeah, because I use mouse. This is pivot, isn't it? Gitu ya, ini pivot ya. Ya, Mbak Fania sama Mbak. Okay. Now, here is Zara. Okay. Here is Sophia. Okay. Zara, the weight is about 450 newtons, yeah. And the distance, Zara sits on a seesaw at a distance of 1.5 meters from pivot. So this distance here is no. I will use with the other color, yeah, blue one. The distance here is about 1.5. Okay, now Sophia weighs 500 newtons. 500 newton. Beratnya Sophia 500 newton. Okay. And then Sophia sits on a seesaw on other side of the pivot from Zara. Calculate the distance from the pivot that Sophia must sit to balance the seesaw. Maksudnya ini loh, jaraknya ini loh berapa supaya terjadi balancing, ya kan? Terjadi keseimbangan. So, the clue is the moment of the right side here, the moment right side must be the same with the left side. Jadi momennya harus sama, maka momen Zara ya adalah force cross distance. Force-nya 450 kali 1,5 berapa? Ini Manus?
675.
675. 675.
675. 450 kali 1,5. 675. Good, very good, thank you. 675 newtons. Apa? Meter. So MS-nya atau moment of Sophia harus sama 675. Nah, sekarang we calculate the distance. Maka distance equal with apa? Moment per
Newton.
force. Momennya berapa? 500. Sorry. Oh, 500. Momennya adalah
675.
Okay, very good. Divided the force. What is the force?
300.
500.
500.
Berapa hasilnya?
1,35.
35.
1.35.
1.7.
Okay, good. 1.35.
1.35.
Okay, very good. 1.35 meters. Okay, good. Okay. Gimana? How, Mbak Fania? Do you understand? I think so. Yes. Okay, very good, Mbak Fania. So the clue, if we discuss about balancing, the right side and the left side, the moment must be the same. Jadi momennya itu harus sama. Tapi kalau force sama, distance-nya beda nggak apa-apa. As long as the moment is the same. Selama momennya sama, kombinasi force atau gaya dengan distance-nya atau jaraknya itu beda nggak apa-apa. Yang penting sama-sama 675. Kalau yang Zara 450 Newton dan 1,5 meter, Sophia 500 Newton dengan 1,35 meter. Maka kita bisa lihat, we can make a conclusion if the force smaller, so the distance must be bigger. Ya, kalau di Zara 450 Newton, di Sophia 500 Newton, tapi jaraknya lebih gede di Zara, ya kan? Zara 1,5 meter, sedangkan Sophia cuma 135. Oke, this is about the proportion of the force and the distance. You have to remember, if we discuss about balancing, so the moment of the left side must be the same with the right side, even though the combination between force and distance is different. Jadi petunjuknya adalah kalau balancing atau seimbang, maka momen gaya di kanan dan kiri harus sama, meskipun kombinasi dari gaya force-nya dan juga distance-nya itu berbeda, tapi selama momennya sama, maka itu balance. Ya. Sehingga kenapa tadi ketika momennya Zara ketemu 675, Ustaz Yugo suddenly directly give the magnitude or the value of the moment of Sofia itu sama
Iya, Ustaz.
sama momennya itu. Oke.
Iya, Ustaz.
Yes.
Tadi 675-nya itu ketemu dari mana ya? Tadi sinyalnya agak patah-patah gitu, jadi kepotong suaranya.
Okay. I will repeat. The moment can be found by multiplication between force and distance. Jadi momen itu hasil perkalian dari gaya dan jarak antara force point with pivot point. Maka 450 kali 1,5 675. Because this is balance ya, balance position or balance condition, maka MZ-nya tak samakan dengan MS-nya. Oke. Kalau MS-nya ketemu, maka D-nya bisa dicari. D-nya dari Mbak Sofia, yaitu momen Sofia dibagi gaya Sofia. Ya, moment of Sofia divided by Sofia force about 500. So the distance of Sofia to the pivot is 1.35 meters. That's all. Okay? You understand?
Yeah.
Okay.
Yes.
Alhamdulillah. Alhamdulillah Rabbil Alamin. And now I think the time is up. Thank you for your attention. Langsung saja ya. We hope we can meet to the next meeting with good condition without COVID-19 ya. Semoga COVID-19-nya segera hilang. Thank you for your attention. See you. Subhanakallahumma wa bihamdik. Asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
See you. Thank you.